Okay, imagine this. You're flying along properly in the soup, relying completely on your instruments. And then suddenly, wham, your airspeed indicator just freezes solid. Or maybe your altimeter gets stuck. That feeling, right, that sudden jolt of what's going on, losing that primary sense of what the aircraft's actually doing. It's not just unsettling. It points straight to a really specific kind of sneaky issue, pitot-static system failure. And the tricky part is it can mess with multiple vital instruments all at once.
Exactly. And that's what we're doing today, a real deep dive into how you actually spot these failures, these insidious failures, and crucially, what immediate actions you need to take right then and there to keep flying safely. This isn't just about ticking boxes for the BIR exam, This is absolutely vital stuff for real-world IFR flying, especially in the kind of Cessna you're likely training in, goes way beyond the basics. So let's just quickly break down the system itself. The pitot-static system, it's kind of the unsung hero back there. Its whole job is just providing pressure inputs, simple air pressure. But those inputs feed your airspeed indicator, your altimeter, and your vertical speed indicator, your VSI. So what this means in the cockpit is pretty straightforward. Without it working right, you're basically missing some of the most fundamental flight data you need.
Okay, yeah, fundamental is the word, so it's critical. But what's like the first kind of failure we might see? How does it show up right in front of you? Let's say just the pitot tube gets blocked, maybe some ice or, I don't know, a wasp. What happens then?
Well, it's interesting how specific it can be. If only the pitot tube opening gets blocked and, yeah, ice, bugs, mud daubers, we've seen it all, it really only affects your airspeed indicator initially. It'll just freeze. Simple as that. Stuck at whatever speed you were flying when the blockage happened. Now, here's where it gets a bit counterintuitive. If the drain hole in the pitot tube also gets blocked, then the airspeed indicator can start acting like an altimeter. Seriously. You climb, trapped air expands, shows higher airspeed. You descend, air contracts, shows lower airspeed. Completely wrong.
Whoa, okay. So not just frozen, but actively misleading you in a weird way.
Exactly, misleading. And that's why, for practical flying, forget just the textbook answer. The real skill is spotting that discrepancy immediately. Your ASI is saying one thing, but your attitude, your engine RPM, your pitch, they're telling a different story. You have to use those other clues, your known power settings for level flight, climb, descent, to estimate your actual speed. Cross-check everything.
Right, that makes sense. The instruments are suddenly talking gibberish, and you need to figure out what's real based on basic airmanship, attitude flying. Okay, but what if it's not the pitot tube? What if the static port gets blocked instead? That sounds like it might be more widespread.
Good question, because yes, a blocked static port causes much bigger problems. It affects all three pitot-static instruments, your altimeter. It freezes right where it was when the blockage occurred, just stops dead. Your VSI reads 0 constantly. Doesn't matter if you're climbing like a rocket or descending fast, 0. And the airspeed indicator, now this is where it gets really tricky. It doesn't freeze, but it reads inaccurately. Specifically, it'll read lower than your actual airspeed when you climb and higher than actual when you descend.
Lower in a climb, higher in a descent. Why is that?
Well, think about it. It's getting the correct ram air pressure from the pitot tube, right? But it's comparing that to a trapped, incorrect static pressure. As you climb, the real static pressure outside drops, but the static pressure inside the instrument case is stuck higher. So the difference between pitot and static pressure seems smaller than it really is, meaning it reads low. Descend, and the opposite happens. The outside static pressure increases, but the trapped pressure is lower, making the difference seem larger, so it reads high.
Ah, okay, see. It's about that differential pressure calculation being messed up because one input is frozen. So for a GA pilot flying IFR, maybe single pilot, spotting that set of conflicting readings quickly is absolutely vital.
Crucial. Absolutely crucial for control and awareness. Your immediate action, if your aircraft is equipped, and many Cessnas are, is find that alternate static source valve and pull it. That introduces cabin air, which isn't perfect, but it's usually much closer to the real static pressure than the blocked port. The instruments will likely read slightly off, but they'll start behaving correctly again, showing changes in altitude and airspeed. So boiling it all down, diagnosing these things, it's all about that constant cross-check. Do the instruments agree? Are they telling a consistent story that matches your power setting and attitude? If something feels off, investigate. Don't ignore it. And managing it. Number 1, fly the aircraft. Attitude and power. Keep control. Use what works. Maybe your GPS ground speed gives you a clue. Maybe just knowing your pitch and power settings is enough. And don't ever hesitate to declare an emergency. That's what it's for. ATC can help with vectors, no gyro approaches if needed. Understanding how they fail helps you trust what is still working. That's key to making safe choices under pressure.
Yeah, it really brings it home. Understanding these Pitot-Static failures isn't just academic, it's fundamental to safe, confident IFR flying. This deep dive, hopefully, gives you a real shortcut to that essential, potentially life-saving knowledge.
Absolutely. And maybe the final thought to leave you with is this. What does this all really mean for you? It means being a truly sharp instrument pilot isn't just about rote memorization for an exam. It's about building that critical thinking muscle. It's about managing the unexpected when you're alone in the clouds, using your knowledge to actually see through the confusion of an instrument failure. That's how you ensure you always keep flying safely, no matter what the gauges try to tell you.